So welcome to today's lesson. We still continue with the Laplace inverse, and in today's lesson we are going to learn to find the Laplace inverse of this particular expression here. So please don't forget to like the video and please subscribe to our YouTube channel. Thank you very much. So note that when you have a function f of t and you find the Laplace of that function f of t, you get a certain function which is a function of s, right? So when you have that function which is a function of x or that function of s already, and you want to get the f of t which gave you that f of s, you have to find the Laplace inverse of this. So to find the Laplace inverse of this will give you your f of t. Okay, so that's some small notation there. So that means that in this question we have our f of s to be whatever we have here. So that's our f of s equal to this from the question. Okay, so when we have this, what we do is that we try to you know decompose this using a partial fraction. And so using a partial fraction, know that we have two factors here. For the denominator we have s minus 3 and we have x squared plus 4, and this s minus 3 here is linear and s squared plus 4 is quadratic, right? So most of the times for the linear we mostly have a over s minus a. Then when it is quadratic, we have plus bs plus c, then x squared plus b, whatever we have there. So that means that here we are going to have a over s minus 3, and for the quadratic part, s squared plus 4, we are going to have bs plus c over x squared plus 4. So we resolve it into partial fraction and we get this. Alright, so after getting this, you have to solve and find the values for our a, b, and c. So when you find the LCM of this expression here, you're going to get s minus 3 or multiplying x squared plus 4 here. I hope you can see that. Alright, so that means that we are going to multiply a by everything we have here, that's s squared plus 4, b by everything we have here, so bs plus times s minus 3, and c by everything we have here, so c times s minus 3, all over the LCM, the denominator. Alright, so you realize that the denominator here and that of here is the same thing, right? So that means that we can equate only the numerators. So equating only the numerators, we have what we have here, and from that place we try to multiply or do our multiplication. So doing our multiplications, you are going to get as squared plus 4a plus bs squared minus 3bs plus cs minus 3c. Then after that we try to group like terms. So you realize that we have x squared here and s squared here, so we can have a plus b. We have sc and sc, so we can have minus 3b plus c, and these are the constants, so 4a minus 3c. So after grouping the like terms, then we try to compare the coefficients. So you realize that the coefficient of x squared here is a plus b, that of s squared here is 5. So in our first equation, we are going to get a plus b will be equal to 5. In our second equation, we compare the coefficients of the s's, both at the left hand side and at the right hand side, and that is going to give us negative 3b plus c equals negative 4. So negative 3b plus c equals negative 4, and the constants gives us 4a minus 3c equals negative 7. So after this process, you have three systems of equations which are supposed to solve simultaneously to get values for a, b, and c. So from our first equation, making a the subject, you can see a is equal to 5 minus b, and we would like to substitute that into equation 3, so this equation. So wherever you find a, we put 5 minus b there. So making that substitution, you are going to get 4 times 5 minus b minus 3c equals negative 7. Then when you do this multiplication, you get 20 minus 4b minus 3c equals negative 7. and simplifying this further gives us negative b 4b minus 3c equals negative 7 minus 20, and this finally gives us negative 4b minus 3c equals negative 27, and this is equation 2, and there's a new thing we found, so we name it equation 4. So realize that solving equation 4 and 2 simultaneously, they are all, we have them in terms of b and c. So you get b to be 3 and c to be 5 when you solve it. So now we have values for b and that's for c. But note that our a was simply equal to 5 minus b, and we have b to be 3. So a will be equal to 5 minus 3, which will give us 2. So now we have values for a, b, and c, where our a is 2, our b is 3, and our c is 5. So when you make that substitution, you are going to get 5s squared minus 4s minus 7 over what we have here equals 2 over s minus 3 plus 3s plus 5 all over x squared plus 4. Note that when you're resolving, we had a over s minus 3 plus bs plus c over s squared plus 4. And our a is 2, that's why you can see this here. Our b is 3 and our c is 5. So we have this. But you should know that when you have something like 4 plus 2 over 2, this is same as 4 over 2 plus 2 over 2. Right? So that means with this particular expression we have here, is the same as 3s over s squared plus 4 plus 5 over s squared plus 4. I hope you get it. So you realize that this was our f of s. So we've been able to use partial fractions to get this to be our new f of s. So we are supposed to find the Laplace inverse of this f of s that we have here. So the Laplace inverse of that will give us 2 over s minus 3 plus 3s over s squared plus 4, then plus 5 over s squared plus 4. So we can decide to bring the 2 out, and since the Laplace operator is linear, we can run it through our expression. So we get 2 out, Laplace inverse of 1 over s minus 3, then plus 3 out, Laplace inverse of s over s squared plus 4. I hope you can see that. Then plus 5 out, Laplace inverse of 1 over x squared plus 4. So now we are supposed to find the Laplace inverse of this, that, and that. Right? So find the Laplace inverse of the first one, that's 1 over s minus 3, is going to give us e3t. And this is because Laplace of EAT is simply 1 over s minus a. So try to get the relation. So by now you should know the Laplace of some simple functions, because they help us a lot to be able to answer questions of this type. Alright, and know that the Laplace inverse of s over s squared plus 4 is simply cos 2t, and this is because Laplace of cos at is just s over s squared plus a squared. I hope you get it. So here we have 4, so a is the same as 2 squared, so cos 2t. And when it comes here, Laplace inverse over 1 over s squared plus 4. So note that Laplace of sine at is a over s squared plus a squared. So here, Laplace of 1 over s squared plus 4, we are supposed to get some 2 here, right? So that means you bring the 2 here, but multiply our expression by 1 over 2, so that in a way they cancel out to get this. I hope you get it. So we get 1 over 2 times Laplace inverse of 2 over s squared plus 4, and this is the same as sine 2t, then times the half here, right? So that's the Laplace inverse of 1 over s squared plus 4 is the same as 1 over 2 times sine 2t. So now we found the Laplace inverse of those 3 expressions that we had. So substituting them into our formula, we have 2et and 2e3t plus 3 cos 2t plus 5 over 2 sine 2t, and this happens to be the Laplace inverse or inverse Laplace of the expression that we had over there. So thank you very much.